Welcome to today's session. As in the previous sessions, we have seen amplitude modulation, definition of amplitude modulation, waveform representation of amplitude modulation. In today's session, we are going to see the equations representation of amplitude modulation. As the definition of amplitude modulation states that the amplitude of the carrier signal varied with respect to the instantaneous variation of input message signal. With that definition, here we can write a standard equation of amplitude modulated signal, which it is represented with S of t will equals to AC cos omega ct multiplied with 1 plus MA cos 2 pi FM t. This is the standard amplitude modulated equation where MA is modulation index, as modulation index is defined by AM by AC. AM represents amplitude of message signal, AC represents amplitude of carrier signal. We can represent the above equation in time domain and as well as frequency domain. So first we will observe the time domain representation of amplitude modulation. AC cos 2 pi FCT plus mu AC by 2. Why we got here the term cos of 2 pi FC plus 2 pi FM into T, cos of 2 pi FC minus 2 pi FM into T is means it is, if you open the bracket here, we can write the above equation in this way. As the first term into, if you open the bracket, it will multiplies with 1. So it is AC cos 2 pi FCT. Then plus MA into AC will be the amplitude, where MA modulation index can also be represented by mu or MA, so that here the representation is given with mu, and carrier of amplitude AC. Why we got 1 by 2 means, if you observe, it is cos 2 pi FCT multiplied with cos 2 pi FMT. It is in the form of equation cos A into cos B. As cos A cos B, the formula, standard mathematical formula is 1 by 2 cos of A plus B plus cos of A minus B. So by that formula, we are representing this equation here. We have opened this bracket so that we can represent this above equation, standard amplitude equation in time domain representation in this way. So mu is nothing but mu is the other representation of modulation index. So mu AC by 2 cos of A plus B, where A stands for 2 pi FC plus B stands for 2 pi FM into T, plus again the amplitude mu AC by 2 cos of 2 pi FC minus 2 pi FM into T. Now if you observe in this equation, the first term AC cos 2 pi FCT represents the carrier signal with amplitude AC and frequency FC. Then coming to second term represents the upper sideband frequency. We call it as upper sideband frequency with an amplitude of mu AC by 2. Coming to the second term, that is here the third term, mu AC by 2 cos 2 pi Fc minus 2 pi Fm into T. The term represents the lower sideband frequency with the amplitude mu AC by 2 with the frequency Fc minus